Hey guys, it's primary and secondary tutorials here today, and here I'm going to introduce you to the parent function of quadratic inverses, and also introduce you to the transformations and how to plot them, and what that parent function actually looks like in terms of coordinates. And so here, our parent function is equal to f of x is equal to the square root of x. And so here we can see that with our coordinates. Well, the square root of 0, our x value, is 0. The square root of, well, you can see me writing down here, square root of 4 is equal to 2, so that means our y will be equal to 2. And the square root of 1 is just 1. And so here you can see on the right is what that parent function actually looks like on a graph. And here are the actual coordinates of that parent function within the graph. And next, I'm going to show you how to do transformations, or at least introduce you to the formula you can use. And so here's our formula for transformations. F of x is equal to a square root of b times x minus h plus k. And so here you can see our a is equal to our vertical stretch or compression. Basically, are we moving towards or away from our y-axis? B is horizontal stretch and compression. Are we moving closer to or away from our x-axis? And horizontal shift is just up and down, and vertical shift is just left or right. But some things do get a little bit tricky, and you'll see that as we come up. But one thing I am missing here is reflections, and I will get to that very shortly. And here is our formula, including our reflections. So the negative in front of the a is our reflection over the x-axis, meaning our y's are going to opposite. And our negative in front of the b is equal to our reflection over the x-axis, meaning our x values are going to opposite. For example, 4 will turn into negative 4, or negative 4 will turn into 4. And so here's our practice problem for the day. F of x is equal to negative 2 square root of 0.5 times x plus 3 minus 4. And so my suggestion would be is to identify your easy transformations first, and that'll be left 3, as you can see, is our x plus 3, and down 4, as you can see, in our minus 4. So let's go to this negative 2. We see the negative in front of it, so that means that'll be a reflection over the x-axis. And the actual 2 behind the negative will be a vertical stretch of 2, meaning we're getting tighter or closer to our y-axis. Now let's look at this 0.5, and another way you can look at it is 1 over 2. That'll actually also be a stretch of 2, a horizontal stretch of 2. And coming up, you'll see the nuances that come with this and how some things are reciprocated and opposite. So our b value, just like you just seen, is always reciprocated. So just like you saw that 1/2 or that 0.5 turn into a 2, here's an example. 1/2 will turn into 2, and 2 will turn into 1/2. Now what's another nuance? Our h value. That will always be opposite, because you see in the formula it says negative h, which means any number that is input into our h value will become either negative if it's a positive number or positive if it's a negative number. So if you were to input this 5 into our h value, it would be left 5. So now, how do we make our parent function and this problem go hand in hand? Well, I'm going to show you what the actual coordinates would look like and how they change, and then we're going to graph it. So first we have to identify or form the formulas we'll be using to change our x and y values. So first we realize our x is moving to the left, so it'll be x minus 3, and our y is going down, so it'll be y minus 4. And then along with our other transformations, we now have 2y minus 4 and 2x minus 3. I apologize for my typo. I meant to type minus 3. So don't get confused on that. And we have that reflection over our x-axis. And so that's why we have the negative with the y and not the x. Because reflecting over the x-axis, all your x values become negative. Or positive depending on where you start, but here they're going to turn negative. So we have 2x minus 3. I make another typo. I apologize. I do fix it here in a second. And negative 2 times y minus 4. So negative 2 times 0 is 0. Minus 4 is negative 4. Negative 2 times 1 is negative 2. Minus 4, that's negative 6. Negative 2 times 2 is negative 4. Minus 4 is negative 8. And so let's go to the other side. 2 times 0 minus 3 is negative 3. 2 times 1 minus 3 is negative 1. And 2 times 4 minus 3 is 5. So let's graph it. And just by rough estimation, and we're going to start way down low because our starting coordinate value is negative 3, negative 4. And then we have negative 1, negative 6, and 5, negative 8. And just to help you identify where these coordinates are, I do plot them. And there you go. Thank you very much.